Now that we understand entropy and information gain, let us see the decision tree algorithm. Now it will be very easy for us to understand the whole algorithm of decision tree, how a population is considered and split into different segments, so that each segment is really useful to take any business action upon. So the major step is to identify the best split variables and best split criteria. So how do we actually find out those variables which will split the whole population into segments that are pure, basically segments that can be acted upon easily, segments that can be classified as, yes, this is a buyer segment, yes, this is a responder segment. So that way, so once we have the split, then we can go ahead and segment level. At each segment we can actually further drill down, so we can start at the root, segment it out, and then each segment can be taken again, it can be drilled down based on the same criteria. So the whole algorithm of decision tree in coding language or usual algorithm manner, if we see, start with leaf node or start with the node, and then find the best splitting attributes. There are multiple attributes. Find the best splitting attribute. How do we find the best splitting attribute? Based on the information gain. For each attribute you calculate the information gain. The one with the highest information gain, obviously that is the best splitting one. So for example, in this case, we'll calculate the information gain for age, we'll calculate the information gain for gender. Looks like gender has a better information gain. Yeah, gender wins when we compare age and gender. So that's how we compare two attributes. So that's how we find the best splitting attribute, by comparing information gain across for all the attributes. Split the node using the attribute. So once we finalize the attribute, then you split the node into two segments, so you have the whole population. So out of all the variables, you calculate the information gain and find the best splitting attribute, and then split the node based on that best splitting attribute. Let's say if gender is the one, then you will have male and you will have female so that is how we split the node. Now go to each child node, so go to male and then repeat the step 2 and step 3. That means again you consider rest of the variables. Now gender is anyway gone. Again, if you consider rest of the variables, can we split this further to make it more pure? We keep on doing that, so that we can finally arrive at few segments, and we already know their characteristics. Let's say if there is a segment here, we know its characteristic, it is male, and then later on whatever variable is chosen, based on that we can find out the characteristics of that segment. Finally, whether that is a good segment or bad segment based on the output that it is giving, or sales segment or responder segment, or bad by lone defaulter segment, etc. We start with the root and then we segment it out based on the splitting criterion, that is information gain. Once we split it, again we repeat step 2 and 3 and continue further. Now when do we stop? So we keep on doing this, and each leaf node, the one has each leaf node, finally we reach to a position there is only one element left. That means there is no further splitting possible. So that is one way, that is one criteria which we can stop. Our algorithm runs out of attributes, so there are only two attributes. So gender is the first one, age is the second one. That's it, we are done. We don't have any other attributes, or maybe 3 attributes. After that there are no other attributes. That's where we can stop. Or no further significant information gain. This is important. So even though there are attributes left, even though there are some more, each of these segments have enough number of samples, but there is not much of information gain. So here the entropy is like, even by splitting it we are not gaining much of the information gain, and impurity is still remaining the same. Then there is no point in expanding the tree, because we are not actually gaining any additional information from there. So in that case also we can stop. So each load contains examples of one type. Our algorithm runs out of attributes, there are no further attributes, or there is no further significant information gain. gain, then we can stop the decision tree algorithm. So that is the overall decision tree algorithm which is used for customer segmentation. We take the overall population and divide it into segments. Let's take an example to understand the decision tree algorithm in a better way. Let's start with the data set that we have taken. There are 14 observations, a simple data set. We have variable called gender, we have variable called marital status, and ordering the product or not. There are customers who are going to order the product or not. So overall there are 14 customers. Okay, the 4 customers have ordered the product, 10 customers haven't ordered the product. Now there is a variable called gender which is male and female. Out of gender, male 7 people ordered, 1 did not order. Female 3 ordered, 3 did not order. Similarly there is marital status. So which attribute to consider? First, shall I split the whole population by gender, or shall I split the whole population by marital status is the question. So simply we calculate the information gain for gender, information gain for marital status. The one with the higher information gain should be given the first preference of split. So there are 2 variables. The one with higher information value need to be given the first preference for splitting. There are 2 variables here, gender and marital status. Let us calculate their information value. So for gender, the information value, entropy before the split minus entropy after the split, or average entropy or the weighted average entropy after the split. So entropy before the split is 86%, so 4 positive 10 negative. 86% is the impurity at the root level. So entropy for gender equal to male. At that split there is a 54% entropy impurity. There is a 100% impurity at gender equal to female. Similarly for marital status we calculate the each node level entropy. Now information gain for overall gender is information or the entropy before the split, impurity before the split, that is 86%, and entropy after the split. So the weighted average is 8 divided by 14 into 54. That is the individual node entropy and the node weightage. Node weightage can be found from, out of 14, 8 are male, so node weightage can be found from number of items within that node, so that is 8 by 14. So 6 by 14 is female node weightage. The information gain is entropy before the split, that is 86, minus entropy after the split. So overall information gain is 12. So for gender the information gain is 12. Similarly when we calculate for marital status, for married entropy is 0%, impurity is 0 because it is very pure segment, all of them are negative, and for unmarried the entropy or the impurity is 72%. So information gain for marital status is 86.3 minus information the entropy after the split, so the information gain for marital status is 60.5. So marital status has higher information gain, which means marital status need to be given higher preference, which means the first split attribute should be marital status, or out of these two which one should be given higher preference for splitting, that is marital status. Similarly we take now we will consider the whole population, then we start splitting it based on marital status, so married and unmarried. So because marital status has higher entropy, if required we will further do the drill down for each of these root or child nodes. Again we go ahead and do another split. It is not required, then we can leave it at this point. This is already pure, all the married customers are negative only, so 9 people are married, all of them are negative. There is no further drill down required here. If there is a requirement then we'll do it, or we'll not, we can leave it at that point, but the process remains the same. We take the segment and we consider all the attributes. The one with the higher information value should be given higher preference for splitting up the whole population. So once again the decision tree algorithm, you select with a leaf node. At the beginning the leaf node is the root itself, the first node itself is the leaf node, and find the best splitting attribute. We calculate information gain for all the attribute. The one with the highest information gain is the best splitting attribute. Split the nodes using that attribute, and then go to the child node and repeat step 2 and 3 again and again. That means once you have the leaf node, you have the best split already taken, then after splitting you will have the child nodes. Once you have the child node, go to each child node and see further best split attribute, then split it. So we repeat the process of splitting again and again. So when do we stop? Whenever there is no further examples, or when there no further records in a particular segment. When the algorithm runs out of the attributes, there are no further attributes, and then there is no further significant information gain. Just by splitting we are not achieving any information gain, then there is no point in going ahead, so we can simply stop it there.